first thing I like to do when looking at compressor questions and steam air questions is just write down all our givens. So we'll start over here, and we'll say, so we have air on the left side in a compressor, and then we have a steam turbine, so water. P1 air is equal to 98 kPa, and T1 air is equal to 295 Kelvin. P2 air is equal to 1 MPa, and T2 air is equal to 620 Kelvin. And then over on this side, pressure 1 of water, P1 water, is equal to 12.5 MPa. And then T1 water is equal to 500 degrees Celsius. And then P2 water is 10 kPa. And they don't give us the second temperature for our water, so I assume we'll be looking for that. Okay, now let's look through the question. So it says, and then it also says the quality of the steam exiting the turbine is 0.92. So we can say X equals 0.92. And steam flows through at 25 kilograms a second, so they're giving us our mass flow rate. So m dot, which is our mass flow rate, is equal to 25 kilograms per second. Okay, great. Now that we have everything written down, it's easy. We can see it all very nicely. Perfect. Okay, first thing we're going to do, so we're going to see what they're asking. So they're asking for determine the net power that can be delivered by the generator. So we're looking for our work dot, right? The net power. Yeah, so using this equation right here, should be on your equation sheet, hopefully. We can assume this is equal to 0. Adiabatic. That basically means that Q dot is equal to 0. So, and then we have the equation, our work is equal to m initial, each one, we don't have any velocity, so we can get rid of those. So simplifying this down, each one minus h2. And then we could say that's for our air, and then plus m dot of our water, h3 minus h4. Okay, so now we have the equation that we need to solve for, so we know that we need to solve for h1, h2, h3, h4, and then our m dot of air, because we were given our m dot of water already. Okay, so now starting with air, we'll take a look at our air tables. Okay, so we have our air tables. I'm just going to make it big for 1 second, just so we can see what we're looking for. So we're looking for H2 and H1. We have our temperature, so we know our temperatures are 295 Kelvin and 620 Kelvin. So we're looking for 295 and 620. So at 295, our H is equal to 295.17. So we can say H1 equals 295.17, and that's in kilojoules per kilogram. Kilogram units is super important in thermo, so always remember to write them down so you don't forget. And then 620 at 628.07. 628.07 kilojoules per kilogram. Awesome. I'm going to get rid of this for now, just so we have more space to work with. I'll just make it really small. Throw it to the side. Okay, so now that we have our equation, so now that we know what we're looking for and we have our equation, we have found H1 for air 1 and H1 for air 2. So now we'll look for H1 and H2 for water. Okay, so here's our water table. So this is for superheated water. So we're using superheated because in the question they say it's steam, so we know it's superheated. So we can go straight to our superheated water tables. And looking here, we don't have 125. So we have 12.5 MPa, which is equal to, using our conversions, 125 bar. We don't have 125 bar. We also are looking for it at 500 degrees Celsius, which we don't have. So we're gonna have to do something called interpolating. If you know how to do this already, just feel free to skip ahead, but I'm gonna just go to the next page just to show you guys how to do that. Okay, so now we're looking for our H value, our entropy, at pressure equals 125 bar and temperature equals 500 degrees Celsius in the superheated area. Looking here, so we actually don't have the temperature we want either, because it's that, but to find that, we're just going to divide them by 2. So because the 500. So because the 500 degrees that we're looking for is in between 520 and 480, and these are linear, so if we take these two values, add them up and divide them by 2, it'll equal these two values added up and divided by 2, which will just be 500. So I'll do that now so that makes sense. So we'll just do it under, so pressure equals 120 bar. So 500 degrees is equal to delta H. Delta H, which is equal to this value, so P bar. So for this one, it would be 3,293.5 plus 3,401.8 all over 2. And that would give us H at 500 degrees Celsius and 120 bar. Yeah, so that's our H at 120 bar. And now we'll do the same thing to find out on this side. So P equals 40. So we have 3,264.5 plus 3,377.8 all over 2. And that equals 3,321.15. Okay, so perfect. Now that we have our two H values, I'll show you guys how to interpolate. So I like to draw this little graph over here. It doesn't make sense right now, but I'll explain it. 1 second. Okay, yeah, so basically what we're doing is we have this formula, and we basically just plug right into the formula. It's super simple. So the formula is y prime, which is what we're looking for. So in this case, it would be our H at 120 bar, 500 degrees Celsius. Yeah, so this is the formula. So basically what we want to do is we want to set one set of values as our x and one set of values as our y. So for our x, we're going to use values that we know. So we know the pressure of H at 500 degrees Celsius. We know the pressure for all three. So it would be 125, 140, and 120. And then the corresponding values are basically going to be our other values. So we're looking for y prime, which is our H at 125. So that means x prime is going to be 125 bar. And then the other ones, it doesn't really matter as long as you stay consistent. So y1 has to be in sync with x1, if that makes sense. So for this case, we're going to set 120 as 1 and 140 as 2, just to make it easier. I usually use a smaller number. So y1 in this case would be, so again, y is the value we don't know, so the y would be the h values. So y1 would be this value right here, and then x1 would be 120, and then y2 would be 3321.15 minus 33. It's a little bit tight over there, but again, these are just these numbers right here, and then our x's would be 140 minus 120. Yeah, perfect. Then you put this in the calculator, and that will give you your y bar, in this case, our h value. And that, if you put that in, plug that into your calculator, you should get 3,341.025 kilojoules per kilogram again. And then we can continue with that value over here. Awesome. So now that we solved for our H3 value, we just have to find our H4 value. So looking for our H4 value, we don't have T2, but we do have our pressure, and we are given a quality value. So what that means is it's basically a percentage of which the steam is water. So the easiest way I know to explain this, let's say you have liquid over here, liquid plus vapor, and then vapor on this side. If we were 100% liquid, we'd be anywhere past this line, right? We'd be on this side of the thing. If we were 100% vapor, we'd be on this side. And then if we're anywhere in this middle zone here, which is where we are, we can have a percentage, right? So let's say you're over here, you'd be like 80% vapor, 20% liquid. If you're over here, 20% liquid, or 20% liquid, 80% vapor, so on and so forth. So basically all this is saying is that we're somewhere close to here. So we're almost fully vapor, but we haven't yet transformed. We haven't fully yet phase changed. So knowing this, we know that we're in the saturated region. So looking at our water chart for the saturated water, we can solve for our H value. All we have to do is find our pressure, so 10 kPa. Yeah, so looking at our water table here, and we know that we're at 10 kPa, and if you convert that to bar, it's 0.01 bar. So looking here, that would be this value right here. And yeah, so now we know the H is somewhere between this range. So if we look at our formula sheet again, we should have a formula that can solve for that. And our formula is H is equal to X H G plus H HG minus HF minus HF plus HF. Yeah, so now we know all our values, so we'll just plug. Awesome, and then once we've plugged these all in, we can put this in our calculator, and that'll give us our final H value. And if you plug that in, that'll equal 2,393.27 kilojoules per kilogram. Awesome. Okay, so I'm just going to get rid of some of the stuff to clean it up. Now the only thing we're missing is the flow rate of our air. So we can calculate that. And something I forgot to mention from the beginning is they also give us our flow rate of our air. So we don't have to calculate that, which is 10 kilograms per second. Awesome, so now that we have all that, we can go ahead and plug all these values into our formula. So W dot is equal to 10 kilograms per second times our H values. So H1 minus H2, 295.17 minus 628.07, and that's kilojoules per kilogram, sorry, plus our M dot water, which is H3, 3,341.025 minus 2,393.27. Put that in your calculator. And you should get 20,364.9 kilowatts, and that is your final answer. So I know it seems a little bit hard of a question, but I promise you, if you just break it down, take it step by step, and write down all your givens, you can definitely, yeah, so if you have any questions, feel free to let me know in the comments, and I can get back to you as soon as possible. Thanks.